The first set of notes that we have in the examples for particle motion and rates of change is that we want to look at ones that are essentially going to be pre-calculus based problems, in that what you're going to see is that what you're given is you're going to be given your position function. So here in example 5, I'm algebraically giving you your position function. And if we look at the next page here in example 6, I'm giving you the graph of the position function. So these are almost a little bit more like pre-calculus in that you're starting from a given position function. That's usually not what happens on the AP, but it's going to help us practice the skill set of the concepts that you need for the FRQs on particle motion. All right, so taking a look at this, for t greater than or equal to 0, our function is given as this nice parabola, pretty easy one. Pay attention to the problem with your units, because when we look at our units, that is going to be something that you're going to need to give for each problem, and we have time in seconds. All right, so we take a look at the first example. Find the displacement of the particle during the first 2 seconds. So your displacement is knowing pretty much that you're going to take your position at 2 minus your position at 0. On the AP, you do want to make sure that you go ahead and you show what you're doing. So here's the formula that I'm doing, and then you calculate it. And I'm going to leave a little of the detail out, but I'm assuming you can do arithmetic and plug and chug. So S of 2 is going to be -1 minus S of 0 is going to be 3. And so that's going to give us -4. So, and you want to put units, so you want to think about what this is. Since this was a position and your position is in feet, this would be -4 feet. Now, what that means, and in terms of interpreting this, is what we're saying is that the particle is 4 feet. We're moving along a horizontal line, so left of the starting position after 2 seconds. All right, so knowing what we're actually finding is good. All right, now average velocity. So going back to our kind of the chapters that came before, average velocity is going to be our displacement over our change in time. So show your difference quotient and make sure that you're going to say we're going to do during the first 4 seconds. So S of 4 minus S of 0 over 4 minus 0. Show your formula. And then in terms of your calculation, that would be just for you to do really quickly. You could have shown 3 minus 3 over 4 minus 0 as where you are. I prefer you do this and then calculate it. 0 over 4, which is 0. And your units on this, the top is your displacement, feet. Change in time is going to be seconds, so 0 feet per second. So on average, since your position, your displacement is actually 0 for the first 4 seconds, where you started is the same place where you ended up. So you actually end up with an average velocity that happens to be 0. Right? Your instantaneous velocity when t equals 4, so you have to know that you're trying to calculate S prime of 4, or which is also V of 4. Right? Either way that you're going to look at it. Now to do this, I will go up here and I like to write down the formulas I'm going to use, which I'm going to need the derivative, S prime of t, which is going to be 2t minus 4. And then you can come down here and make sure you don't have a linkage error, that you have formula and then value where you're evaluating, plug it in. 2 times 4, 8 minus 4 is 4. Is that correct? Yeah, 4. And then feet per second. And don't get confused about the units. Remember that another way to write this is dv, or sorry, undo that, ds dt. The units of s are feet. The units of t is seconds, feet per second. So make sure you put your units on. And then just to remind you, because they're going to want you to do this, is to go ahead and, if I had to interpret this, remember your 5 parts to the interpretation. You would say at 4 seconds when the what position is increasing, which way, at 4 feet per second. So our 5 parts, when, what, which way is it going, What are the amount by how much and units? So that puts your 5 parts of your interpretation. All right, find your acceleration at t equal to 4. So acceleration is going to be a of 4, which is going to be our second derivative at 4. And if I was going to use my notation to kind of remind myself what it is, this would be your second derivative of s with respect to time twice. All right, we'll go ahead and do that. Again, over here, I like to show the formula. So s double prime of t would simply be 2. It's constant. So our acceleration is constant for the entire problem. The acceleration is going to be 2, and it is going to be feet per second squared. If you are going to do your units, because it's feet per second, because it's also known as over here, I'll see if I can fit it right in on the side, it's dv dt. And so dv, the units of velocity are feet per second. The units of time is seconds, so it's feet per second, which happens to be feet per second squared. And again, the whole plug and chug, or we don't have to plug and chug because we know what the answer is, because it's constant the entire time. So we would simply say 2 feet per second squared. Right? So that gives us our acceleration. And then, and if I was interpreting this, I didn't talk about this the last time when we were doing the notes, but if I was going to interpret it, you would say at 4 seconds, the velocity, because what is changing in the second derivative is the velocity, which came before, is increasing at the constant 2 feet per second squared. So notice I still have the same 5 parts: when, what, which way, how much, and units. The constant part you don't have to put in, but it's nice additional information. All right, taking a look at the next problem. At t equal to 4, is the speed of the particle increasing or decreasing? Now remember, speed and velocity are not the same things. So do not tell me the speed is increasing because the acceleration is positive. That's not going to be enough in this problem. You have to look at both parts. And we want to know what's happening at 4. So I'm going to put the because over here because I'm just going to look up. At 4, v of 4 is positive. And there's always 2 things to look at. Your acceleration at 4 is also positive. So they are the same sign, so they are working together. So our conclusion is going to be that the speed is increasing because both the velocity and the acceleration are the same sign. When they work together, speed increases. When they work in opposition, different signs, then speed will decrease. But you need to have both of these statements in. You have to say both acceleration and velocity in order to get that speed is increasing. All right, when is the particle moving to the right and to the left, and at what values does the particle change direction? The particle moves to the right when your velocity is positive. It moves to the left when your velocity is negative. I already have my velocity function up above there, which is my 2t minus 4. V of t equals 0 when t equals 2. So that's my critical value. Remember, we're only doing 0 and above. It is a positive sloped line, so it's minus 0, would be negative there, and then positive over on this side. That's my velocity. So my position function, you can look at this. This would tell me then left. This would tell me right. So it's the same kind of idea with our increasing, decreasing. So we would say particle moves, let's do left from 0 to 2. And, you know, it's one of those things about what's actually happening at 0. The particle was actually moving when time started on this. And so I would probably put a bracket right there because at 0, it is a negative value on that. So 0 is just our starting point. So we would say it moves left, bracket 0 to 2, because our v of t is less than 0. And the particle moves right from 2 to, do we have a limit on this, or are we going forever on that? 2 to infinity, I would say 2 to infinity, there's no limit. So 2 to infinity, because v of t is greater than 0. And then the last part, at what values does the particle change direction? Notice it's tedious, but you have to answer the questions, so you have to make sure you write it. Changes direction at t equal to 2 because v of t changes signs. Okay, so notice that we're always referring to the calculus reason, which is about the velocity. All right, and then find the total distance the particle travels during the first 4 seconds. So what you need to do is when you're talking about this is I went left for a while, stopped, turned around, and went right. So I need to figure out how much I went left. All right, so my total distance equals the total going left plus the total going right, because I went left and then right. So for this one, I need my displacement from 2 to 0. And you do put absolute value around it because you want to make sure that it is a positive value. And then you do your displacement for the next times. When was I going right? And we're going the first 4 seconds. So it would be the displacement from 4 to 2. And we would then make that positive because we don't care what direction we're going in because displacement will be positive or negative. We find the displacement, make it positive, and add those together. And so this, since we already calculated to be 2, and it was a positive number, and then here, the position at 4 was 3, the position at 2 ends up being -1. I will let you plug and chug for those. And so we end up with a final answer of 6 feet. So it went left 2 feet, went right 4 feet for a total of 6 feet. All right, so that's the first example 5 in these notes, and I'm going to go to the next one. And I'll start that in the next video, but just kind of give you a heads up. This is still going to be a pre-calc problem because it's this idea where I'm giving you the position and then asking you questions. I'm just trying to get you to learn all the different ins and outs so that when we actually get to the calculus part, which is where they're going to give you, if you look at the very next question, I'm going to give you the velocity curve. And this is what you will see more often on the AP. But let's go back to this. I want to pause or stop this video, start example 6 in the next video.